Mute on.
Randy, Eric, Stephen, the virtual floor is yours.
Thank you, Andy. It's a pleasure to be here with you today and here on the 100th webinar of INCOSE. We're here to talk about integrating program management and systems engineering. This is Eric Rebentisch. Randy, Illiff, and Stever Townsend are joining with us. They will moderate the discussion, especially with questions and answers towards the end of the presentation. And I'll give the bulk of the presentation leading up to that. So our motivation with this was that consistently over decades, we've seen that large-scale engineering programs tend to have cost and schedule overruns. And this is an example from the U.S. Department of Defense. This is their acquisition portfolio. And you see that on average across many large programs that you see significant cost overruns in engineering development and across the overall program. So in this weapons portfolio of, I think it's a $1.5 trillion, average cost growth of $300 billion and almost 2 years of schedule overrun. This is well documented, so this is accessible, but we've seen evidence that this kind of overrun in programs occurs in other industries and sectors. And so we wanted to understand a bit more how can we tackle this problem, especially given many large-scale programs either currently underway in many sectors, especially in infrastructure and energy, or planned in the future. We as nations and society can't afford to have this kind of poor performance. Here's an interesting counterexample. This is Space Exploration Technologies, Spacex as it's often known. It's a company that produces rather complicated machines. These are boosters for achieving orbit for satellites, other payloads for the International Space Station, but they also have a crew inhabited capsule in development that will be used by NASA and its astronauts. Over its short existence, it's been around for about 15 years. It's managed to produce 4 new engines, over 100 new space qualified technologies. On the right-hand side of this screen, you see a screen capture from their website. This is what they have up, and they actually advertise their cost per launch, which is the lowest in the industry. It's truly an amazing organization what they've been able to accomplish, and they have big plans. They were founded with the vision of going to Mars and colonizing another planet. So how have they done this remarkable thing over the last 15 years? Well, first of all, they focused on creating a simple product. They realized that existing launch systems are very complicated, and the cost of the vehicle itself is just the tip of the iceberg when it comes to cost and complexity. So they really simplified the design, and they use common parts wherever they can. There are a number of things that they do with respect to the design and the architecture of the product that have made it easy to design, easy to adapt and modify, and easy to produce. Another thing that they've done is they've co-located most of their work into one location. And on the left-hand side of the screen, you see their building. If you are on approach to Los Angeles Airport, you can often see their building outside of the left-hand side of the airplane. This is where most of their work happens, from engineering to production. They do testing off-site, but most of the work happens here. And it facilitates rapid, easy communication between people. They also use advanced digital design tools and communication tools to help that communication with those that are off-site. they're vertically integrated. They make most of what they launch in-house. They have very simple supply chain, and this helps them because without contractually binding agreements with other parties, they can move very rapidly to introduce new design concepts and so forth. They have responsible employees that are directly responsible for the success of elements of the mission of the vehicle, and this is embedded into the way they've organized their work, so that there are always responsible people who deliver the required capabilities. And finally, they have a culture that really emphasizes shared responsibility, understanding risk and driving it away, of communication and collaboration. And this is very important to the way they work. So what's the result of all of these best practices, if you will? Well, they have the lowest launch cost in the industry. They're rapidly expanding their market share, introducing new products at an amazing rate. And it's a real counterpoint to what we see in other kinds of organizations that produce complex products, that they're delivering low-cost capability on time. Yes, they have setbacks, but they're able to recover from them very quickly because of this organizational system that they've created. Back in 2011, the leaders of PMI and INCOSE came together and they looked at the state of large engineering projects and their performance. And they said, our organizations can do something about this. Too often we think that systems engineers and program managers have a mindset where they think they can work on their own in their own separate areas, and they can make their programs successful, essentially not by working together. And in fact, what happens is that we have the kinds of program failures that I've talked about previously. So what they articulated at the time was a vision of what we need is that all of the members of the program team, the program managers, the systems engineers, and other technical disciplines have to come together, that they have to work in a holistic or more integrated fashion to deliver value to all the stakeholders. And that if they work in this more integrated fashion, that the outcomes are going to be better. Well, so they created this alliance between PMI and INCOSE. MIT, my group at MIT had been working with PMI and INCOSE previously on work on applying lean principles to engineering program management, and it resulted in this guide to lean enablers for managing engineering programs. So we were a natural fit to help with understanding more how you bring program managers and systems engineers together to work in a more integrated fashion. So beginning in 2012, PMI and INCOSE started with a survey of program managers and chief systems engineers. And so the survey was designed specifically that only program managers, not project managers, but program managers and chief systems engineers could respond. And they generated over 650 responses internationally to a survey that looked at the roles that program managers and systems engineers played in their organizations, what kinds of standards and certifications and backgrounds they had, how they worked together, whether they were experiencing any challenges in their relationship, a number of questions. And we were involved in the analysis of the survey data. We have some publications that you can access on PMI and on my website at MIT that resulted. We gave presentations at PMI congresses and INCOSE symposia. But what we found after analyzing the data and reflecting on it was there was a lot more that we did not understand than we did about the way these two disciplines work together. So we followed up with participants of the survey and had interviews, and we asked them in more detail how they managed, for instance, their knowledge, their culture and organizational structure, what kinds of practices and tools they used, what kind of competencies they valued or required in their people. And this resulted in additional reports and presentations. We wanted to be more systematic than these interviews, and so we created another survey that looked specifically at integration. I'll tell you about these results, but I wanted to let you know that we spent about 3 years doing research to try to understand this problem better and talk to a lot of industry practitioners and experts in government to understand what aspects of work and the way people work together enable them to be more successful, and specifically with regard to program management and systems engineering. So one of the things that we found early on, and this is one of the measures from the survey, was unproductive tension, and that's defined as any type of relationship that results in significant challenges to the program outcomes. And here are some attributes of unproductive tension that we found. The team members, and specifically the program managers and systems engineers, fail to communicate to establish a common set of objectives or vision shared by all members of the program. That the individual groups or disciplines were focusing on achieving objectives that were defined by their own discipline rather than the overall program. They were having problems working together to meet those shared objectives or outcomes, and they didn't particularly value the other's role or contributions when they were working together. And the result was that they had this unproductive tension. If you reflect on this, probably all of us have worked on programs or projects during our careers that had attributes of these issues. There's tension, that people didn't work together, and this was one of the things we found in a few organizations in the survey. Not the majority of them, fortunately, but in a number of organizations, a significant number, they had these kinds of relationships. On the other hand, we asked about their integration between the two disciplines. And these were two separate questions, one looking at unproductive tension, the other looking at integration. But what you see is almost the exact opposite of what I just mentioned. So they had a shared set of objectives that were defined by the success of the overall effort, and everyone in the program knew what those objectives are or were. They had clear understanding of everyone's roles and how they contribute to achieving those objectives. They respected the value that each of the different disciplines brings to the analysis, to the decisions, to the overall solution. And there's a strong emphasis on promoting collaboration over competition. So it's everyone wins as opposed to individual groups or individuals win in any kind of conflict. And we'd seen these kinds of behaviors in case studies over the years of a few highly successful programs. This just reinforced and clarified that integration is really represents a way of working that is, as we will see, much more productive. So we formalized our definition of integration. And what would you see when there is effective integration between program managers and systems engineering? Well, they're sharing information very freely. There are no restrictions. They work together in a very collaborative fashion. They make decisions together. They coordinate and consult with each other frequently. And as a result, they have rather rapid and effective decision making. They make decisions, they make high quality decisions, and they do it quickly. And the sum of our study was that rather than there being a few silver bullets, a few common best practices that you apply and become more highly integrated, that integration really is a function of the organization's ability to combine these different practices together, both systems engineering and program management practices, tools, techniques, and knowledge, and they do it in a systematic approach to whatever challenges they face, and they do that in the service of achieving a shared goal or objective in these complex programs. It really is about many different elements coming together in a deliberate fashion to achieve this higher level of performance. And what we saw in the results that organizations that had a much more deliberate approach to trying to make these things happen were much more likely to be more integrated and more successful. So here's the framework that we use to show the different aspects of integration. So we start with effective integration in the center. And what do you have to do to have effective integration? Well, there are 4 dimensions that we talk about. Processes, practices, and tools, the things that you do to work, the organizational environment or the climate that is set for the way people interact, the specific competencies that people have to work together in a more integrated fashion. And then there are some contextual factors. And what we demonstrated in the research was that when you have effective integration, the program performance is higher. And so I'm going to tell you a little bit about each of these elements. I'm not going to talk as much about the contextual factors, but they'll be addressed in some of the illustrations. So in processes, practices, and tools, we have essentially, we focus on how do people work and what are the ways or tools or methods that they use in order to work together. And there are tools that people can use in their disciplines that give an answer. It may be a very high quality answer, but it allows them to work in isolation. And what we focus on really is there are tools that help people to work together and encourage them to share and to collaborate. So these tools and practices really emphasize communication and building common understanding. They establish clear expectations of another person's contributions. They typically will have approaches documented and outlined for how you coordinate and how work flows through the system, who is involved and who needs to be making decisions or communicating, for instance. They will identify specific points where groups have to come together to share information or to make decisions. They identify ways to identify problems and seek joint solutions. They are continuously updated. These organizations that are highly integrated also share attributes with other organizations that, for instance, are continuously improving. So what did we see in the surveys and the other research? Well, they tended to have, these organizations that were highly integrated tended to have combined standards. So they had tailored their standards, ways of assessing their expertise of their workforce in a way that emphasized integration and collaboration. They had clearly defined roles and responsibilities for their chief systems engineers and their program managers. They would focus on use of best practices or leading practices and continually assess them. So they did assessments on a more frequent basis, and they adopted boundary spanning systems. I'll give you some examples in a moment on how this was done in a specific program. On the organizational environment, these are the structures and behaviors and norms, the assumptions that people use when they work together, how they interact with each other, and the nature of their relationships. And what we saw was that organizations really sought to narrow the divisions between the program management and systems engineering disciplines. We consistently saw very strong emphasis on team building, building respect and collaboration and trust between the various teams in the program, including the management and the engineering teams. So elements of the organization environment, a very strong value on knowledge sharing, and also sanctions sometimes against the knowledge hoarding or retaining knowledge that should be seen by all the team members. And this could include, by the way, suppliers as well, so beyond the organizational boundaries. Clear reward and recognition of those who work together. We pretty consistently also see strong executive support for operating in this fashion. So the organizational environment is not specific to a program typically, but often spreads across the entire organization. Finally, the other element is developing integration competencies in people, and specifically having competent people, yes, with standards and certifications, but also having clearly defined roles, having education and training that helps each discipline to better appreciate the contributions and the role of the other disciplines. Sometimes we would see examples of program managers who had previously been chief systems engineers, not as often seeing a chief systems engineer who had been a program manager, but often a shared understanding. And many people have asked us, shouldn't you just have one person filling both roles? Well, sometimes that works, but if you have a very large, complex program, you really need to have people at the top of their game in both roles. And so developing understanding and awareness and ability to team is very important. And then there's a clear management of the integration competencies of the workforce across the organization. Let me share an example with you. Well, before I do that, I'll tell you about whether this makes a difference. So we looked at a survey sample of over 160 programs with this integration framework. And one of the things we wanted to know is if you do have these attributes in place, does it make a difference on program performance? In this chart, the black bars in the chart are the more highly integrated programs in the sample, and the gray bars are the ones, the programs that had less integration. They were lower, had lower level of our integration index. And in all cases, with program schedule, program budget, meeting the client requirements or the client satisfaction, there was a significant difference between the more highly integrated programs and the lower integrated programs. Now, this is based on a scale, so there's not an absolute measure of integration. So, does the 14% improvement in program budget relate to 14% improvement in program performance on budget? No, it's an indication that these programs do significantly, on average, produce better results. And then the individual results of your program may vary, of course, depending on many circumstances. But we do have pretty clear evidence to suggest that you get better performance from higher levels of integration. So here's the example I mentioned earlier. This is an aircraft program, the F-18EF Super Hornet. It's a carrier-based aircraft that's used by the U.S. Navy. So this is a program that is unique in that it was an military aircraft program that was delivered on time, on budget. And there are very few programs of that category that can boast that kind of performance. You can see in the lower right-hand corner a number of different military aircraft over the years, and the F-18EF is the only one that met its initial budget performance. And you can see that some of these are exceeding budget by a third, by almost a half. And the average overrun is 22%. So this is a unique airplane. How did they do it? Well, let's start with the contextual factors, because I didn't really talk about those up to this point. This is a program that was born out of a challenging situation. It's the prior aircraft program, the A-12, had been canceled because of poor performance. The Navy needed to replace aging aircraft on in its carrier fleet, and because of the challenging circumstances created by the cancellation of the A-12, the program budget was fixed, and there was quite a bit of oversight from the Congress and from the DoD to any follow-on program. So the program leaders got together, and they got the government program leaders, the contractor program leaders together, and they had a number of working sessions where all the systems engineers, the other technical disciplines, the life cycle disciplines like logistics and maintenance, everyone got together and said, okay, what are we going to do to produce an airplane that is going to meet our program requirements? And they really looked hard at risk. They looked hard at the requirements, and they eventually reached a consensus on what they could do to create an aircraft that would, a program that would deliver as promised. So this was a derivative program. It was a follow-on to the existing F-18 Model CD. This airplane is 40% bigger. It has, 25% bigger. It's a bigger airplane. It's been grown. It has 40% fewer parts. It was redesigned. It's aerodynamically very similar to the prior airplane, so there was low risk there. It used a growth engine of the existing engine, so it was kind of low risk there. They reused 90% of the avionics system, so low risk there. They used a lot of the existing organizational relationships and supply chain, so again, low risk. And they really kept a focus on using mature technologies, and any new developments were sent to another program that would be integrated later. So that was the context. They really focused on having a manageable, predictable scope. And then when it came to the kinds of things that they did for execution, they had, for their integration processes, practices, and tools, they developed a work breakdown structure that was based on the aircraft's product architecture. So it was a 5-level structure. At the top was the airplane system. And then you go down through the different levels to the point that you get to, say, the outer wing section. And there were teams then that were created according to that work breakdown structure. But the work breakdown structure was also used to model the tools that they used. So they created a common database for managing the airplane, for the integration work. They had their work breakdown structure. It was linked to their earned value management system, and they would meet on a weekly basis. All of the teams could report to their requirements in their earned value management system, and also on their progress. And finally, they also flowed down their budget. So each of the IPTs, even at level 5, had a weight budget, they had a cost budget, they had a schedule set of requirements, And if they were staying on their budget, then that was great. If they were having problems, they had to work them out. If they couldn't work them out, then they could go up to the next level and see if someone else could share their budget. So it was a very organized system. They had a number of electronic advanced design tools that they used that were integrated into this common database. So there was a high level of awareness of what was going on across the program. In the organizational environment, this is probably the most noteworthy because they had the program managers from the government and from the contractor and the supply chain working together. And they really were modeling how the teams were supposed to work together to the rest of the program. As I mentioned earlier, they had these IPTs that were built across functional groups that brought the different groups together, including management and engineering, and they were organized around the work breakdown structure and the product architecture. They had a very strong emphasis on communication across boundaries, and that translated into a culture of shared responsibility. There was no blaming for problems was allowed. Someone couldn't say that was this person's problem because we are failing to meet our objectives. It was everyone's shared responsibility for success in the program. On the people side, they developed, they selected for people that had these attributes of integration and collaboration and the things that I've described, but they deliberately looked to develop people with these skills and capabilities. They tended to then rely on those capable people to make decisions where the work was performed. So they had rapid decision making as a result. Now, what was the outcome? Well, you remember the original problem was that the Navy needed airplanes. And so if you could just compare the Air Force, U.S. Air Force with the U.S. Navy, the U.S. Air Force average fleet age is 27 years, so the average age of the aircraft is 27 years. Now, 10 years after this program, the Navy fleet average age is between 15 and 18 years. The program delivered all of the aircraft that it needed to, that it was originally intended to deliver, and in fact, they've begun to deliver more. So you could say they've grown market share. They've increased, they've added derivative, excuse me, aircraft. And because they finished their engineering development program underweight, which again is another remarkable thing for an aircraft program, they have growth capability built into the airplane. So this is a very high-performing program, but it also shares or illustrates many of the practices that you see in this integration framework of working together, making decisions quickly, and sharing information. So these kinds of programs don't happen all the time. In fact, they're often fairly rare. If integration is a challenge for your organization, it may in fact represent a cultural challenge. And so we looked a lot at how you change the culture and the way organizations work. And this is a framework from PMI for managing business change. There are other frameworks out there for making high-level changes. But the bottom line is that if you're thinking that integration is a valuable thing that you would like to pursue in your organization, you're probably going to be looking at some kind of change activity. And these change efforts typically involve at least 4 stages. One, a strategic phase where you say, okay, here are the challenges that we're facing. Here's what we need to do. You might then go to some kind of assessment to say, okay, where are our strengths and weaknesses? How ready are we to take on a change like this? You might make some plans to find some specific projects as part of the change program, and then move into execution. There are lots of resources available on managing these things, But I wanted to just give you an example of how this kind of change plays out. This is a study that we did in BMW in their engineering division a few years ago. And it was a major change initiative that really was driven by the corporate strategy. They had to reduce their engineering costs essentially by about a third in order to stay competitive and meet their corporate goals. The engineering division was seen as kind of a key player in that because they had to increase their number of product offerings. They needed to reduce the cycle time to get products out. So they started a change program called E3. It's based on original German words, but we essentially translated that to mean that they had to have exciting products, they had to have efficient processes and structures, and they wanted the team members to be really excited about their work. And then this was further broken into some big top-down projects that worked on things like validation without the use of physical prototypes. They had an initiative that was looking at workforce engagement through bottom-up change initiatives like lean or continuous improvement. And then they had an effort to get all of the people in the organization on board to have create a common mindset. Because of the time, I won't go into a lot of details on this, but let me just note that one thing that was unique about this was it started with the senior leaders. And the senior leaders themselves went through training to understand how to be change agents, and they personally were involved. Okay, so these were the heads of all of the divisions, like systems engineering, mechanical engineering, electrical, all of the different divisions leaders started. They then went and trained their next line leaders, and it was essentially leaders train the workforce. And by the end of 2 years, all 8,000 engineers in the division had been trained by their managers. And each manager had gone through multiple training sessions to demonstrate what the goals were, to let everyone know how they were going to play a role in achieving those goals, to talk about how they work together to improve communication and coordination, and also some major projects that introduced significant changes and improvements in the way people work with new tools and so forth. So they had a combination of top-down initiatives and bottom-up improvements. You can see in the bar chart towards the on the lower left of this slide that the dark blue lines were the results that were achieved by major initiatives. Those were where the major improvements came in the early days of this program. But over time, the bottom-up initiative, the workforce engagement, self-organized improvement initiatives really started to take hold and resulted in significant improvements in the engineering output. So what was the outcome? Well, first of all, this initiative was started just before the global economic crisis. And during the crisis, BMW managed to stay profitable, not at a great level, but still was profitable, and didn't lay off any workers as a result of the downturn, in contrast to other automakers who, in some cases, went into bankruptcy. Between 2006 and 2011, they grew their total revenue by 40%. They delivered 21% more vehicles. Total vehicle quality increased by 32%. They expanded their model range by 30%. The number of car models or derivatives in the pipeline increased by 53%. So they were doing a lot more work with the same workforce. And these were, while there were a lot of derivatives, the complexity of these vehicles actually increased. They had more capacity to add more features. So BMW really emerged from the downturn and moving forward in a much stronger position, which met their corporate objectives of being an autonomous, high-end luxury automobile manufacturer. But it illustrates over a period of, say, 5 years, the amount of commitment that the organization and its leaders had to bringing about this kind of change and producing these impressive results. Well, so that's a quick overview of integration between program management and systems engineering. Let me quickly just tell you what we've been up to. Over a period of years, we've been slowly building the ability to share our message. We have a LinkedIn group, the Program Management Systems Engineering community launched on LinkedIn in 2014. We have an alliance working group between PMI and INCOSE. We have a book that I'll tell you about in a moment. And then finally, there's an INCOSE PMSE working group that was established in 2016, and it's ongoing. As I mentioned, we have a book that really captures all of these lessons from our research. The bottom line is that the better integration between program managers and systems engineers produces better results in programs, and it really is a function of a system of working together in many different ways to achieve that outcome. It's targeted to professionals, and in fact, the people who wrote the book, even though my name is on the front, there were just a lot of really sharp and experienced people that provided the content. From the PMI community, from the INCOSE community. We had reviewers from INCOSE and PMI who gave us feedback on the manuscript, and we had other academics as well. So this is really the work of a lot of very talented people, and I'm really happy to have been able to work with them. And I think it provides a richness to the book and in the content. Going forward, certainly the best resource out there, I have to say, is on integrating program managers and systems engineers, is this book. It's got a lot of content. It's not the only thing. We hope that we can, by building communities, get your insights, your stories, and keep growing our knowledge base. We have, as I mentioned, the LinkedIn community. There's a PMI community website that will be coming soon. The INCOSE PMSE working group is building its own website. Again, all of these are things that we hope will bring the community together to share their insights on their own experience with program management and systems engineering integration. And if you're interested in seeing the precursor, the guide to lean enablers, you can download that for free from my website at MIT. We have a number of events going on this year. I would draw your attention to late September, when there will be a virtual conference on integrating program management and systems engineering. If you happen to find yourself at the INCOSE IS or other conferences listed here, stop by. Some of us will be there, and we would be happy to have a conversation with you. And with that, I'm going to open this up to questions. I think Stephen and Randy will probably moderate at this point.
So, gentlemen, thank you for a great presentation on integrating program management and systems engineering. So, Randy, Stephen, if you can look through the questions. I see we have a couple that have come in. Don't forget to unmute yourselves by dialing *6 on your telephone keypads, Randy and Stephen.
Yes. Thank you, Randy. Thank you, Eric. Just a really quick comment. As you listen to the presentation and you take into account all of the factors that Eric described that make a program successful, it is very much a system engineering interaction between program management and the SE discipline and many other abilities that we've all come across that results in the emergent property of highly successful programs. So from the view of system engineers, there's actually a confirmation of many of our belief sets at work here, as well as a remarkable tool to carry forward towards Vision 2025 and other factors. Stephen, any quick comment from the PMI perspective before we launch into the Q&A?
Just that we found several examples over the course of the study of organizations where integration is highly valued and delivers strong results for those organizations. So that's why we're being evangelists with regard to the book, because we feel that there's a lot of opportunity here for organizations to achieve strategic benefits from better integrating program management and systems engineering, but also in building stronger collaboration between the management side and technical side of their business. So we're very passionate about advocating that position. We do have a few questions here. The first question, did you look at correlations of program managers and systems engineers' past experience under people competence? In particular, for program managers with past experience in systems engineering and systems engineers who have managed projects in the past.
So let me take that one. Yes, and we saw this primarily anecdotally. People were quick to suggest that program managers and systems engineers that had shared those roles in the past were more effective. And I think that's probably where most organizations are getting the benefit. Our concern is that in a very large program or a very complex program, that doesn't scale very well. That you can't rely on one single person to manage the complexities of program management and systems engineering in full depth, so that they're effective in the program. But you need a team of people working together. So yes, there is a correlation between program managers having a systems engineering background. We saw that in the evidence that we collected, but I think there's some limitations there.
Yeah, and Eric, just to further elaborate on that, one of the key things that we found in the study was individuals who were systems engineers were more likely to transition between roles. So they were more mobile in being able to move back and forth between the technical side and the management side. But we also found that the management side tends to be much more formally organized. So program managers tend to have very clear position descriptions with clear accountabilities and responsibilities, and we found that that wasn't necessarily the case on the chief systems engineer side, which was one of the causes of unproductive tension, where roles, responsibilities, accountabilities between the two weren't necessarily clear. So that was one key issue. But again, as we looked at examples of good program management and systems engineering integration, NASA stood out, for example, because NASA, along their career track, they have 4 or 5 different levels. And whether you're on the management side or the technical side, you have to complete training in the other discipline as you move up the ladder so that you continue to have that understanding of, if you're on the technical side, you understand the management issues and considerations. And similarly, if you are on the management side, you understand the technical terminology and issues and challenges so that they're better able to understand each other and work together much more effectively. We have 2 questions that are very similar, and that is related to having a copy of the presentation. I believe Andrew is going to wrap up with information on this webinar being recorded and archived so that individuals who are on this can review it again, and individuals who missed it would still have access to it. Randy, you were going to say something?
Just a very quick build on your comment about PM and SE talent working together. As we move outside of the traditional aerospace community, you'll find a lot more recognition of what the terms program and project manager mean, although they're often conflated into a single definition. But my own experience in the commercial sector has been the term system engineer is completely foreign to many audiences. and that only through the work of PMI has the concept of professional program or project management been introduced over the last 15 years. So there is a time lag between the dimensions, and that time lag in understanding gets exponentially more difficult as you move outside of the traditional areas. So that was also something that was encountered in the research I wanted to share.
I guess I would probably just observe that what we found was that you really need a kind of system approach to integration, and so the talent management is a very important part. And what I've seen in years of research in related areas is that you can have a really talented program manager, perhaps with a systems engineering background, that can make a program successful, and that is despite all of the other factors that are working against that. So what you really want, if you want to have consistent execution, you really want to work on all of these different elements. And so, if you have effective collaboration and communication and decision-making, then you can have the systems engineering roles and program manager roles be separate disciplines, not the same person, and still have a successful program.
So we have addressed all of the questions in our queue. Unless anyone has any additional questions, I guess we'll turn it back over to Andrew to close us out.
Well, thank you again for a great talk, and thank you to the audience for your questions and your time. You go to the next, oh, there you there. The next slide shows our upcoming schedule. The next webinar was scheduled for 2 days' time. Jackie Pratt's talking on system of systems, but we think we're going to have to postpone it probably to next week or the following week. So watch this space for further information on that webinar. We'll be offering, then on the 2nd of August, Paul Clements will be presenting a webinar on feature-based product line engineering, ISO standards initiative, and recent industry experience. Then we'll have additional webinars will be offered on the 3rd Wednesday of each month through 2017. We won't be holding one in July because that would clash with the International Symposium. Talking of which, the next slide shows if you could go to the next slide, please, shows that the 27th INCOSE International Symposium will be held in Adelaide, Australia, on the 15th to the 20th of July of this year. Registration will be open through to the end of this month, and you'll find more information on the symposium at the website shown. Next slide, please. Please note that the 11th INCOSE Great Lakes Regional Conference will be held in the Twin Cities, Minnesota and USA. Next slide, please. As mentioned earlier, you can now claim 1 PDU credits towards your systems engineering professional recertification by attending this webinar. You may also claim this credit retrospectively for INCOSE webinars that you have attended and where attendance meets the qualification requirements. Please contact INCOSE if you wish to know which webinars you attended and if you met the qualification requirements. Next slide, please. If you're a member of the Project Management Institute, you may also claim a PDU for attending this webinar. Here are the details on how to claim, and I'll leave this slide up as we end the webinar so that you can take down the information if you need to. We will be publishing this recording. The intention is to publish it not on the INCOSE Connect, which would only be available to INCOSE members, but on the public INCOSE website. And with the author's permission, the presenter's permission, we will also include a PDF of the charts which were shown in this presentation. I presume that will be okay, Eric, Randy, Stephen?
Yes.
Yes.
Okay. Thank you again, and goodbye.